Example 3, they want to write this in standard form. So they want us to, as we say, write it out. So we multiply these two together and get this. Double distribute. And then we distribute the 3 to get here. To find the x and y intercepts, well, since it was already in factored form, we can see that if x is 1, it makes y 0, or if x is negative 2, it makes y 0. So those are your x-intercepts. The y-intercept is easy to find if I plug in x equals 0 here and here. I just get negative 6. Since the a value is positive, the parabola goes up, so the cave goes up. And the right end goes up, and the left end goes up. Up. Ooh, that's not right. The right end goes up. This one is in vertex form. Let's take advantage of that. Do you see that the vertex is 5, negative 1? And do you see that it goes down? Well, 5, negative 1 is below the x-axis. So, if you're looking for x-intercepts, it's not going to happen. There aren't any x-intercepts. The y-intercept, easy to find. Plug in x is 0, bang! The y-intercept is negative 26. Since the a value is negative, the cave goes down. The left end goes down. The right end goes down. Now, if we were to plug some stuff in to find the x-intercept, well, y is 0. Instead of multiplying the original vertex form out, let's leave the square term, multiply everybody by negative 1, kick the 1 over to get rid of the square. We root both sides, and you're rooting a negative. Not going to happen. So algebraically, we can see that there isn't going to be an x-intercept. Geometrically, we can also see there isn't going to be an x-intercept. We're going to approach example 4 a little different. They give us the function in factored form, which means that negative 3 and negative 9 will make the function 0, so those are the x-intercepts. Hence the phrase sometimes called intercept form or factored form. Now, remember the idea of symmetry. These two are like twin points on either side of the axis of symmetry. So what's halfway between negative 3 and negative 9? Our friend negative 6. Once we know that negative 6 is the x-coordinate of the vertex, just like before, to find the y-coordinate, plug in the negative 6, and the function will give me my y-coordinate. Plug it in, be careful of your algebra, and you get, let's see, is this right? Positive 3 and positive 9. Yep, that's positive 27. So the question is, find the, in this case, maximum value. Because the a value is negative, it goes down. So the maximum value is 27. It's increasing from here to here. It's decreasing from here to here. So increasing on the left from negative infinity to negative 6. And from negative 6 to the right, the graph is now going down. or decreasing. Okay? The domain, from left to right, all real numbers, and the range from the bottom to the top is from negative infinity up to 27. The y value gives us the top of the parabola, and it does get there, that's why I include it with a bracket. Let's get an idea of what's happening for this parabola, second degree. The a value is positive, so it's going up. Negative b over 2a, the opposite of negative 6 is 6, 2 times 2 is 4, reduce that to 3 halves. Put it in for x, so we can find the y-coordinate of the vertex. Squaring 3 halves, we get 9 fourths. 2 goes into 6 3 times. 3 times 3 is 9. We're subtracting it. We're adding 3. So we multiply this by 2. Reduce. We get 9 halves. Let's talk about halves. Negative 9 is negative 18 halves. And 3 is 6 halves. Common denominator. Hopefully you can do that. And then negative 9 plus 6 is negative 3 halves. So here's our equation in vertex form, because we know the x-coordinate of the vertex and the y-coordinate. There's our vertex. So the minimum value of the function is the y value. It's how far down it goes in terms of y. It's increasing from the vertex to the right. It's decreasing to the left of the vertex until it gets to the vertex, left to right. Domain, left to right, forever to the left, forever to the right. Range from bottom to top. The bottom starts at negative 3 halves and goes up to infinity. In example 5, they ask us to write this in factored form and then to find the intercepts. So we multiply this out, we square it first, and then take the opposite later. The plus 1 stays plus 1. And then we combine terms and we get to here. To factor it, it's difficult for me to factor if the first term is negative. So what I do is I factor out. Since they say factor, I can factor out a negative, changes all the signs. And then just don't lose that negative sign and factor what's inside the parentheses. Once it's in factored form, finding the x-intercepts is easy. To make this 0, x could be 1 or 3. But to find the y-intercept, I'd rather go back to here, plug in 0 here, and have negative 3 left for the y-intercept. Same goal here, to find this in factored form, but before I do that, let's grab the y-intercept. Plug in 0, and there's our 9. Hopefully, you can get the y-intercept easily. This factors quite nicely. You can write it squared, or you can write them each separately. I like writing it squared. And so the x-intercept is when this makes it 0. So negative 3 will do that, and there's the x-intercept. For C, 2x times x is 2x squared. And if I want to make the middle term negative 19, If I leave the 9 as 1 times 9 and have the 2 and the 9 get together for the 18, and one more makes 19. Set each of these equal to 0, and this gives me the x-intercepts. Plug in 0 for the x. Easy, easy to get the y-intercept. And watching one of the students, they showed me this method where if you multiply these two, you get 30, and the middle term is negative 17. So what two numbers multiply to give you 30 and add to give you negative 17? Well, negative 15 and negative 2 work very nicely. So all I'm going to do is rewrite the original question. Still has the 6x squared, still has the plus 5. But this negative 17x term I'm going to write as negative 2x and negative 15x. The negative 17 is still there in two parts. And the reason I did it in that order is because these two look good together because they have a 2x in common. Factor it out. We're left with 3x minus 1. And these two look good together, right? They both have a 5. Now I factor out a negative 5. Negative 5 times 3x is negative 15x. And negative 5 times negative 1 is a positive 5. And this better work because now I have the same common factor. Take that out, and we're left with the 2x minus the 5. Set each factor equal to 0 and solve. There's one x-intercept. There's the other. Go back to the original and plug in 0 for x, and 5 falls out as the y